Okay, so welcome back. So today we have again NCERT exercise question. So question is, why does the reactivity of nitrogen differ from phosphorus? So reason is simple. First thing, nitrogen is small in size, and that's why it has ability to form strong p-pi bond. What I said, nitrogen is small in size, that's why it has ability to form strong p-pi bond. So nitrogen exists as N2, and it is N triple bond N. N2 exists as N triple bond N. So due to strong bond between nitrogen and nitrogen, due to the triple bond, huge amount of energy is required to break this bond, and that's why it is almost unreactive at room temperature. Means that energy cannot be met at room temperature. So nitrogen is inert at room temperature and it is less reactive. Okay, got it? Due to high bond dissociation enthalpy, of N triple bond N, N2 is unreactive at room temperature. So it is clear, nitrogen is less reactive because of triple bond. Because of its small size, it can form strong p-pi bond. But in case of phosphorus, phosphorus जो है, phosphorus that in yellow or white phosphorus or even red phosphorus, it exists as P4. Means there is p single bond. Means phosphorus cannot form strong p-pi bond due to its large size. So it satisfies all the valences by forming single bonds. So it exists as P4 in white or we can say yellow phosphorus. So p single bonds are there. There are p single bonds, or we can say they are sigma bonds and can be easily breakable. They can be easily breakable, and that's why P4 is reactive. Okay, and at the same time it has angle strain due to angle strain as well, as because H phosphorus is sp3 hybridized, so it should have angle 109 degree 28 minute, but due to this structure the bond angle is 60 degree. That means it is highly strained ring, so that tries to open up. Okay, and that's why P4 is highly reactive. So you can write, because there is no need to write in detail. Reason being, question is simple. What is the difference in reactivity? So we have to prove nitrogen is less reactive or almost unreactive, and P4 is phosphorus is reactive. So first reason is nitrogen is small in size, so it forms strong p-pi bond. So nitrogen exists as N2, and that's why it is difficult to break this bond. and that's why it is unreactive. And in case of P4, in P4 there are, you can write this structure and you can write there are PP single bonds which can be easily breakable or which can be easily broken, and that's why P4 is reactive. That's it. On the same line you can prove why nitrogen exists as N2 but phosphorus exists as P4. So same reason, nitrogen can form strong P-pi bond, therefore it exists as N2. Phosphorus, due to large size, it cannot form strong P-pi bond, so it satisfies valency by forming sigma bonds, single bonds. Okay, so it exists as P4. Why nitrogen is gas, P4 is solid? Same reason, due to atomicity, due to molecular mass. Because nitrogen exists as N2, therefore its molecular mass is low, intermolecular attractions are less, and that's why it is a gas. But phosphorus, it exists as P4 because of its large size, it cannot form strong P-pi bond, and as P4 has higher molecular mass, van der Waals attractions are more, intermolecular attractions are more, therefore P4 is a solid. So say how many questions you can cover, right? Okay, this is P4 and N2. Next is discuss the trends in chemical reactivity of group 15 elements. Okay, so question is, reaction of chemical reactivity of group 15 elements. Okay, so group 15 elements में अगर chemical reactivity की बात की जाए, है ना, तो सबसे पहले बात करते हैं कि देखो, नाइट्रोजन कैन रिएक्ट विद हाइड्रोजन, नाइट्रोजन कैन रिएक्ट विद ऑक्सीजन. ओके, इवन means group 15 elements can react with hydrogen, oxygen, or even metals. Okay, so first of all let us discuss the reactivity. ठीक है, reactivity towards hydrogen, रिएक्टिविटी टुवर्ड्स हाइड्रोजन. तो हाइड्रोजन के साथ अगर रिएक्टिविटी की बात की जाए तो यू नो नाइट्रोजन कैन फॉर्म NH3, phosphorus can form PH3, arsenic can form ASH3, antimony can form SbH3, and bismuth can form BiH3. So this is called ammonia. pH3 is phosphine. Yes, tell me what is the name of ASH3. Yes, write the name. Yes, Anika, reactivity increases down the group, but there are different types of reactivity we are talking about. reactivity towards hydrogen, reactivity towards oxygen. Okay, now tell me the name of ASH3. What we call it? Yes beta, what is the name of ASH3? These are hydrides of group 15. They are most common. NH3 is ammonia, everybody knows. PH3 is phosphine. What about ASH3? It is arsine. And what is SBH3? It is stibine. And BiH3 is bismuthine. So say name you should remember. Okay, ASH3 is arsine, SBH3 is stibine, and BiH3 is bismuthine. Now let us discuss their different properties. At the same time, nitrogen can form N2H4, phosphorus can form P2H4. What is the name of N2H4? It is NH2NH2. Yes beta, what is the name of this compound? NH2NH2. Very good Anika, it is arsine. What is the name of this NH2NH2? This is called hydrazine. And at the same time, nitrogen can form a special type of hydride. This is special class of hydride. This is called hydrazoic acid. So nitrogen can form NH3, PH, phosphorus, PH3, arsenic, ASH3, antimony, SBH3, and bismuth, BiH3. At the same time, nitrogen and phosphorus can form N2H4 and P2H4, and nitrogen can also form this hydride, which is called hydrazoic acid, and its anion N3 negative, that is called azide ion. That is called azide ion. Okay. Now, how do we prepare them? This is the actually these questions are general questions. They are not asked as such in the exam, but it is given as to revise the topic. Okay, so that's why I write the question. Okay, obviously this is question number 7.3, but it can never be asked as such. Okay, discuss the trends in chemical reactivity of group 15 elements, because it is itself a question of 10 marks. So there are 1 marker, okay, 1 mark questions. Okay, so question is like one reaction is given, just complete it, or some reasoning question. Okay, reasoning question of 1 or 2 marker. Okay, when 1 or 2 marker questions are there, you should write 1 or 2 sentence. Okay, like they may ask, what is the oxidation number of nitrogen in hydrazoic acid? Question may be asked as, what is the oxidation number of nitrogen in hydrazoic acid? This may be the question of 1 mark. So first of all, you should know what is hydrazoic acid. So formula should be known to you. So hydrazoic acid, I just told you that this is HN3. Now oxidation number of nitrogen. So when hydrogen is attached to nitrogen, you know nitrogen is more electronegative than hydrogen. So nitrogen get X, and hydrogen, you know, if hydrogen is less electronegative than nitrogen, hydrogen should have +1 charge. So we can write it as 3x plus 1 equal to 0. Means 3x equal to -1. So x is equal to -1/3. That's it. So this type of question may be asked. Okay, done. So now preparation of these hydrides. So to prepare them, first is by hydrolysis of binary compounds. Okay, binary metal compounds. Okay, so like magnesium nitride Mg3N2, hydrolyze this compound. Calcium phosphide, zinc arsenide, magnesium stibide or magnesium bismuthide. See, this is magnesium nitride. I will write their name. Magnesium nitride. This is calcium phosphide. This one is zinc arsenide. This is magnesium stibide, and last one is magnesium bismuthide. Okay, just hydrolyze them. You know, magnesium, calcium, zinc, all of them has +2 charge. Okay, these are the metals. Now nitrogen is N3 negative, phosphorus is P3 negative, arsenic is As3 negative, antimony is again 3 negative, bismuth is again 3 negative, because all of them are attached to more metallic elements. You know, bismuth is metal, that you know, we have already discussed, but bismuth is attached to magnesium, and magnesium is more metallic than the bismuth. That's why bismuth get negative charge and magnesium will get positive charge. Okay, now just hydrolyze them. What are the products formed? Yes, beta. Magnesium is 2+, so it will attract out of H2O, H plus and OH negative. You know, it has H plus and OH negative. So obviously these positive ions will attract negative ion. So Mj OH twice, and nitrogen N3 negative, H plus NH3. So 3 MgOH twice and 2 NH3. That means 3 to the 6. So obviously 6 H2O. Right? Now what about this same case? 3 calcium hydroxide and 2 phosphine. All are, I think, 6. Reason being they are of the same category. 2 ASH3, 3 MgOH twice, 2 SbH3, 3 MgOH twice and 2 BiH3. So these are the products formed. Any doubt in it? I think it is crystal clear to you, because all have same type of metal. Means if we write it as M3E2 plus 6H2O to give 3 MOH twice and 2 EH3, so it is common to all, right? Okay, now next is by reduction of trichlorides. So this is simple. We are doing the group 15 hydrides. Okay, first we write how many types of hydrides are there, then we are doing their preparation. So group 15 element chloride, when it is reduced by using lithium aluminum hydride or zinc in HCl, then we get EH3 plus LiCl plus AlCl3, and this element may be nitrogen, phosphorus, arsenic, antimony. Okay, because this element is group 15, so it can form 3 bonds, and there is one lone pair in every case. EH3, LiCl, AlCl3. Just balance it. So if we balance it, this one EH3, so let us say 4 and 3. So it is 4 and 4th is a 12, 3 and 3, so 9 and 12, right? So this is the balancing. 4 ECl3 react with 3 LiAlH4 to give 4 EH3, 3 LiCl and 3 AlCl3. This is a reducing agent, most common reducing agent which is used in organic chemistry. It is called lithium aluminium hydride. Lithium aluminum hydride. Okay. Now different characteristics of these hydrides. So first one is bond angle. Now when we talk about bond angle, first we draw its structure. If we have any group 15 hydride, this element, group 15 element, has electronic configuration NS2, NPX1, NPY1, NPZ1, right? Now this element has 3 unpaired electrons. So it undergoes sp3 hybridization, because lone pair is always hybridized. So they form sigma bond by overlapping with 1s orbital of hydrogen. So EH3, in EH3 this element has 1 lone pair and 3 bond pairs. So arrangement is tetrahedral, and one of the position of tetrahedron is occupied by lone pair. Okay, so now bond angle depends upon substituent atom and central atom. This is called central atom, and this one is called substituent atom. Okay, this shape is clear to you, right? Now, you know, bond angle is proportional to electronegativity of central atom. Say, if this central atom is more electronegative, then what would happen? The bond pairs are close to it. If bond pairs are very close to each other, then what happened? The bond pair repulsion increases. Bond pair repulsion increases. So bond angle increases. That means bond angle is proportional to electronegativity of central atom, and it is inversely proportional to size of atom. You know, if size is small, then bond pairs are close to it. If they are close to it, the bond pair repulsion is more. Okay, it is size of central atom, right? So to have large bond angle, electronegativity of the central atom should be more and size of the central atom should be less, and at the same time it is inversely proportional to electronegativity of substituent atom. Inversely proportional to electronegativity of the substituent atom. See, this substituent atom, if it is small in size, then and it is more electronegative, so bond pairs are away from the central atom, they are close to the substituent atom, so distance between the bond pairs increases. So if distance between the bond pairs increases, the bond pair repulsion is less. Okay, and that's why bond angle decreases. Okay, so this is the case. So say in this case, because all are hydrides, so substituent atom remains same. If it is remains, we remove it. Now we have only two factors, size and electronegativity. So you know, as we go down the group, size increases, electronegativity decreases. So as size of the central atom increases and electronegativity decreases, that's why bond angle decreases. Bond angle decreases means maximum bond angle is for ammonia, because there is nitrogen in ammonia. You know, nitrogen is smallest in group 15 and its electronegativity is maximum. Its electronegativity is maximum. Now pH3. So you know, in pH3 phosphorus is somewhat larger in size. So as phosphorus is large in size, so what happened? Bond pair moves away from it. Okay, and one more thing, I have not taken into consideration this lone pair, because this lone pair simply every atom has lone pair, so lone pair will repel these bond pairs, and lone pair bond pair repulsion is greater than bond pair repulsion. That's why bond angle is less than 109 degree 28 minute. That is clear because of this lone pair. Okay, but if we talk about the difference in bond angle, then keep in mind that nitrogen is small in size and is more electronegative. That's why bond pair is close to it, and bond pair repulsion is more, so they are more stretched out. If they are more stretched out, their bond angle is more. In pH3, angle is very close to 90, say 93.8 degree around. Or in ASH3, still less, means angle is in 91 point something, I think 93.6, 91.8 degree. So surprisingly, bond angle of these is close to 90, because keep in mind, if you go in higher classes, you come to know this lone pair, this phosphorus in pH3 is not sp3 hybridized, means hybridization is not considered in these cases, because this lone pair is in the pure s orbital. In phosphorus, arsenic, antimony, it is around about 91.3 degree. Okay, and in BiH3, angle is in 90s, exact 90. So in p orbitals, bond angle is 90 and they are very close to 90. So it has maximum s character, means lone pair is in the s orbital only, means it is not hybridized. What I write, this is lone pair in s and 3 unpaired electrons in p, and they undergo hybridization in case of nitrogen. But in case of phosphorus, arsenic, antimony and bismuth, this lone pair is in the pure s. So in p orbitals, bond angle is 90 degree. So see, in BiH3 it is exact 90. That means in this case lone pair is in the pure s. Here lone pair is in maximum in s, slightly in p. Okay, that means these bonds are formed by pure p orbitals. Slight s character is there. That means as we go along the series, as we go down the group, lone pair is more in the s. Lone pair is in the s, means the hybridization part is decreasing, means hybridization is maximum in NH3 and it goes on decreasing. So that means in BiH3 angle is exact 90. That means these bonds are formed by pure p orbitals, because px, py and pz, between px, py and pz angle is 90 degree. They are mutually perpendicular to each other. Got it? But in detail we are not going. I am just saying, because if you see angle here, it is 107.5 or 107.8 degree. Okay, and these are in the 90s, so it is because of that fact that phosphorus, arsenic, antimony and bismuth, they are not involved in hybridization. Okay, but if question is simple, why bond angle decreases, so you just write कि as size increases or electronegativity of the central atom decreases, bond pair moves away from the central atom, so bond pair repulsion is less, so bond angle is decreasing. Okay, right, this is about bond angle. Yes beta, any doubt up to this? This is, I think, called Drago's rule or something like that. Okay, next is your boiling point, properties of hydride. Boiling point, there is NH3, PH3, ASH3, SBH3 and BiH3. Now, you know, electronegativity of nitrogen is 3.0 and electronegativity of hydrogen is 2.1. And what is the electronegativity of phosphorus? Arsenic, antimony and bismuth. What are the electronegativities of these elements? So keep in mind, electronegativity जो है of this phosphorus, see, you can predict like sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So it is like 0.9, add 0.3, 1.2, 1.5, 1.8, 2.1, just add 0.3. So that means electronegativity of phosphorus is 2.1. Okay, even arsenic, electronegativity of arsenic is 2.0 and they have 1.9, means their electronegativity is very close to hydrogen. So NH3 is most polar, but rest of the bonds are seems to be non-polar, because phosphorus and hydrogen, say, both have 2.1 electronegativity, very close to it. 2.0 is very close to 2.1. 1.9 is also very close to 2.1, means they are almost non-polar bonds. That's why NH3 is associated through hydrogen bonds. It is associated through hydrogen bonding, but in PH3, ASH3, SBH3 or BiH3, there is van der Waals attraction. And whenever there is a van der Waals attraction, you know, van der Waals attraction is directly proportional to size, directly proportional to molecular mass, directly proportional to number of electrons. Okay, so you know, boiling point of ammonia due to its tendency to form hydrogen bond is more than PH3 and ASH3, but less than SBH3 and BiH3. Why is it so? Because, you know, as molecular mass increases, van der Waals attractions also increases. Though hydrogen bond is strong, but you know, if molecular mass is very high, van der Waals attractions can be of greater magnitude than that of hydrogen bonding. That's why if we plot a graph of boiling point versus their molecular mass, it is like this. This is NH3. This one is pH3. That means pH3 has least boiling point. Then it is ASH3, SBH3 and BiH3. Because in pH3, ASH3, SBH3, BiH3, there are van der Waals attractions, and as the size of the atom increases, obviously their atomic mass increases, means overall pH3, ASH3, SBH3, BiH3, their molecular mass increases, number of electrons are also increasing. That's why van der Waals attractions are also increasing. So pH3 nearby to NH3, therefore its boiling point decreases. Then it goes on increasing, and then after ASH3, SBH3 has higher boiling point than that of NH3. So order should be like, first we write boiling point of BiH3 is maximum, then SBH3, then it is NH3. See, there is a break. Why NH3 comes on that side? Because according to the rule, it should be here only. NH3 should be here, but NH3 is at this point because of its tendency to form hydrogen bond. If it is also non-polar and there is a van der Waals attraction, if it would be the case, then NH3 should have lowest boiling point. But because ammonia is associated through hydrogen bonding, that's why its boiling point is higher than pH3 and even ASH3, means phosphine and arsine. Okay. (50-50) surprise babua, 50-50. Okay, now melting point. Melting point, because in melting point, every hydride is solid. So in case of melting point of NH3 is maximum, and rest of them, obviously there is an increase, but that is not greater than NH3. So pH3, ASH3, SBH3, their boiling points are, melting point of NH3 is maximum. NH3 is greater than BiH3, SBH3, ASH3 and pH3. So today we have covered bond angle, preparation of hydrides of group 15, boiling point and melting point. Rest of the properties we will discuss tomorrow at the same time, that is 8 p.m. to 9 p.m. Okay, daily there is a class from 8 p.m. to 9 p.m. Now one more announcement for you that I have told you tomorrow as well. Sorry, yesterday, even day before yesterday and yesterday I have told you that I am covering NEET revision of class 11 on noon app from 9 p.m. to 10 p.m. It is daily. For first 21 days I will cover class 11, and next 21 days I will cover 12th, especially organic chemistry. So you can join, but just download the Noon app. It is totally free. There is no hidden cost at all. Just download the app and join my group. That is 21 days NEET class 11 revision course by Suresh sir. Just after downloading and sign up, just search in the search box that NEET chemistry by Suresh sir. Then join my group, and where there is a live class, you can ask unlimited number of doubts. I will solve them instantly, and we can discuss any problem related to your NEET preparation. So you can come live just after few minutes, that is from 9 p.m. to 10 p.m. It is totally free. So just join and first download the Noon app, sign up करें और मेरा group join करें and crack the NEET confidently. Thank you so much, and do subscribe my channel. It is your own channel, and just share with your friends as well, so that they will be benefited by this channel. Okay, so thank you so much to be with me. Bye bye to all.